Today, on how it's made. Steel wool. When it comes to cleaning, it can be your best alloy. Ranges. We have all the elements of this manufacturing process. Carved candles. Making them is a whole new ball of wax. And slot machines. We bet you'll love this story. Steel wool has lots of rough edges and it's very abrasive, but that's what we like about it. It's useful for heavy cleaning and other chores. Mechanics were the first to use steel shavings to polish things. By the early part of the 20th century, equipment was invented to mass produce it, making steel wool a household name. There are thousands of metal threads in each steel wool pad. To make it, they start with coiled steel rod that unwinds through metal guides into a 5-meter-long die machine. It pulls the rod through 6 progressively smaller dies to narrow it and make it uniform. Spools wind up the rod after it passes through each die to prevent any snarls in production. The repeated drawing through the dies reworks the steel's basic structure, doubling its tensile strength. When it reaches the end of the die machine, the steel rod has been reduced by a little more than half. This slimmer, stronger wire will be easier to process. To double-check its tensile strength, they place a sample piece of wire in a testing device. Clamps pull it from both directions. It takes over half a ton of force to snap it, an indication that it's tough enough to be machined. So it's over to the steel wool cutting machine, which spans 15 meters. Here, the wire travels over a series of drums, while 29 blades shave it. Each blade produces shavings thinner than a human hair. Streams of the shavings exit the machine. They make a quick turn around metal guides to merge with others. Each of these steel threads has been cut in a pyramid configuration, which makes it razor sharp. The steel threads wind en masse onto large rolls under the machine, accumulating in one big pack. Next, they line several of the rolls of steel wool on racks and then secure them in place. They pull steel fibers from each roll and bunch them together. Then they thread the bunched up ends through a series of bobbins. They feed the ends of all the rolls of wire to a needle punch machine. Here, hundreds of needles, shaped like fish hooks, weave all the steel threads together to turn it into wool. It's a very basic crochet job, and it produces a long mat of wool that's a suitable density for woodworking. To make household cleaning pads, they bulk up the steel wool even more. They insert layers of needle mat into the streams of steel fibers. This gives it extra strength for big cleaning jobs. The double layered stream then heads over to the needle punch machine to be woven together. Once the steel wool goes onto a final roll, it's wired and ready to be turned into pads for cleaning, sanding, or polishing. Jobs for which its coarseness will definitely be appreciated. The range is where the action is in the kitchen. It's where we whip together meals and perhaps discover our inner chef. But stylish ranges are a fairly recent trend. A couple of centuries ago, cooking was mainly done in cauldrons over fires. We've certainly developed a taste for something a lot more civilized. High-end ranges like this one are hot, and not just in the obvious way. They're an upmarket trend because cooking with one is an experience to savor. To make one of these double oven ranges, they start with a big sheet of galvanized steel. A machine flips it and feeds it to a press. The press folds the sheet twice to make walls for an oven, closing it around the framework. They position the oven bottom on the 3 walls. Automated welders fuse everything together. The back section goes on next. Those holes are for the oven fans. The oven shell gets a porcelain finish on the inside. And then they install elements on the bottom of the ovens. They place fans over those pre-cut holes. More heating elements run along the perimeter of the fans. They lower the oven and wrap it with synthetic insulation to keep it from scorching nearby cabinetry. Side panels cover the insulation and help support the oven structure. This piece of steel will reinforce the base of the range. They fasten several feet to it. The front ones have wheels, so the range can be moved without tearing up the floor. They cushion it with packing foam, flip it, and hoist the oven onto it, next to a smaller second oven that's part of this double oven range. Then they hook up the microprocessor board that controls everything from the fans to the timers on both ovens. They plug it in and test the wiring to make sure it all works. This is a dual fuel range. The burners are fired by gas. This electrical board will sense gas flow problems. They assemble the igniter boxes that produce the spark to ignite the gas-fueled burners. They mount the igniter box assemblies on the cooktop. They install the gas valves on the framework and then slide connectors onto some gas lines and attach them to the valves. On this upscale cooktop, there are 2 gas lines for every knob, one for a low flame and the other for a high flame. They install the burners and porcelain drip pan. The cooktop is now ready to be lowered onto the ovens. This part will hold the knobs. It's called a bullnose, and it's a bit of a showpiece, so they grind and polish it to give it a gleaming finish with no sharp edges. For handling purposes, they protect it with plastic. This machine punches and bends the edges of panels so they can attach them to the sides of the range. At another station, they buff up doors for the ovens, so they'll match the shiny bullnose. After all, presentation counts for a lot when you're making a meal. With the side panels and doors attached, all that's left are a few more finishing touches. And the final product is truly a feast for the eyes. Carving candles is an old German craft, still practiced by artisans. It involves layering different colored waxes and then carving designs that expose those colors and the luminous core. It's hard to beat the radiant beauty of a carved candle, but we'll try not to wax poetic about it. Carved candles are known for their swirls and curls, a look so elaborate that lighting one is an occasion in itself. They start with vats of hot wax in various colors. The candle maker stirs them to circulate the specially formulated dyes. She dips a star-shaped wax core into clear wax and then yellow. The clear wax dilutes and lightens the yellow. She hardens the layers in cool water. She repeats this process between 30 and 35 times as she builds up layers of different colored waxes on the candle core. As the dipping continues, the candle becomes warmer and softer, which will allow it to be carved. The quick dips in water only cool the outer layers. Partway into the dipping, she deepens the grooves in the candle. She resumes dipping and keeps a close watch on the temperature of the water and the wax. If the candle absorbs too much heat, it will become too soft to carve. But if it's too cool, it becomes too rigid to carve. Achieving the right consistency is crucial. It's almost time to carve, but first, she squeezes the drippings together and then slices them off. These multicolored drippings are too attractive to waste, so she shapes them into a mushroom candle. She pokes a hole in the center for the wick. She has just 15 minutes to carve the main candle, or it will be too hard to work with. She slivers the bottom and curls the pieces back. It effectively peels back the layers of color for an eye-catching display. She dunks the row of curls in water to harden them a bit so they don't sag. Here's a twist. She curls each row in the opposite direction to the one before. She carves a total of 4 rows and curls the last slivers up rather than down. Using a square-edged gouging tool, she cuts a windmill design into the upper section of the candle. Then she shapes the wax cutouts into a deck for the windmill. She carves tulips and other designs around the top. She works quickly and with a steady hand. It takes at least a year of training to learn to carve and shape these designs so quickly. This one is a neat trick. She jiggles a straight-bladed knife to cut the fluted edge of a hummingbird wing. One last character, and this carving job is complete. Now she presses a device that's a bit like a cookie cutter around the wick. This forms a well that will allow the candle to burn down the center instead of dripping down the sides, which would ruin the carving. She spins it in a hot pan to melt the bottom so that it's level. And while it's still hot, she presses the trademark sticker onto it. Finally, she dips it in an acrylic glaze. This seals everything to the candle and protects the finish. Once lit, the light from the clear core shines through the designs for real glowing beauty. A San Francisco car mechanic invented the first slot machine in 1895. Its heavy cast-iron cabinet housed 3 mechanically spinning reels. Each one had 20 playing card symbols and an image of Philadelphia's famous Liberty Bell. If you were lucky enough to line up 3 bells in a row, you won the big jackpot, 50 cents. Today's slot machines are glitzy and high-tech. They've got computers for brains and endless game themes and configurations, all packaged in cabinets made of lightweight sheet metal. Workers first assemble what's called the bulkhead, the upper part of the cabinet that contains all the game-playing components, such as the audio amplifier, the circuit boards, the speakers, and what's known as the meter, the electromechanical counter that keeps track of the coins and credit going in and out of the machine. At the base of the cabinet, they engrave the machine's serial number, required by law. Workers install the machine's bill acceptor, into which you insert paper money. Then the ticket printer. When you win, it spits out a ticket to either cash in or feed into the bill acceptor to continue playing. They hook up the arm mechanism you pull to spin the reels. Then the upper door that frames the reels. Then the lower door that frames the button panel. Slot machines have several illuminated buttons for different types of bets. Workers plug a tiny LED behind each button, then wire up the panel. A plastic insert labels each button. Once they finish assembling the panel, they install it in the lower door. Now they take a metal panel with windows for the spinning reels. On the back, they install 2 circuit boards, one to operate the machine's digital scoreboard, the other to illuminate the reels. Then they cover it in glass, treated with a chemical that conducts electricity. Should a cheater try to rig the reels using an electronic gadget, this glass will ground the signal. A decorative window goes over the anti-tampering glass. Then workers install the whole shebang into the upper door. In the lower door, they install a touchscreen video monitor to display the payout information. Casino technicians also use it to configure the machine. Then workers install panels with slots for receiving tickets and for inserting either money or debit cards. And now for the slot machine's most famous feature, the reels. After a machine tests the spinning motion and lights, a worker slots in a plastic strip with printed symbols, 18 to 22 symbols per reel. The reels just snap into place into a waiting electrical connection. Next comes what's called the top box. Workers mount it onto the bulkhead, then install fluorescent bulbs. These will light up the eye-catching artwork on the glass front of the box. With a fully developed body, the slot machine is finally ready to receive its brain, an operating system on a programmable microchip in the machine's internal computer. The software that runs the game is on a memory card. It randomly determines the course of play, but within defined parameters. Essentially, it's pre-programmed to pay out a certain amount at random intervals over a period of time, but less money, of course, than the machine takes in overall. Before embarking on its spinning spree, each and every slot machine undergoes extensive quality control testing. Casinos demand the reliability of these one-armed bandits be a sure bet, because slots generate more than 2/3 of casino revenues.